Start our today's lecture. I think it's on SVM, support vector machine. In our last class, we have started discussion on support vector machine, and we have derived the equation that is the support vector machine with hard constraints. So in this support vector machine hard constraints equation are the optimization problem. Um, we have the objective functions and also we have the constraints. Okay, in our last class we have discussed about that. Our objective is to minimize this function and the constant. This is our constraints. And now our target is to find out the optimal value of W and B. Uh, I think those who are new here, you have to uh, study the first class of support vector machine we have discussed in our last class. And in our last class, we have derived this equation, actually, this equation, and then uh, we want to solve this optimization problem. That means we need to find out the optimal value of W and also the B. That's the target here. For that, we want to utilize one of the optimization theoretic approach, optimization theoretic algorithm that is called the Lagrange method. Okay, so Lagrange method of finding out the optimal value of W and B. Uh, and this is the equation that is called the Lagrange equation. At first, we need to form that, and then we have to find out the derivative of this equation with respect to B and also with respect to W. In our last class, we also have shown that. This is the equation. So what we have to do, uh, we have to take the derivative of this equation, that is derivative of L with respect to B. And if we take the derivative with respect to B, then we got this equation. Okay, the details you can find out in our last lecture. So this is one of the equation, we can say like this one is the equation number 1 maybe. Then the same Lagrange equation, we have to take the derivative with respect to W, and we can see here, if we take the derivative of this equation with respect to W, then you will find this equation. For details, you have to check our last lecture. And then we will derive some of the new equations here using these two equations. Okay, equation number 1 and 2. Like the decision boundary, the equation for the decision boundary, we can just put the value of W here, this W, and the decision boundary, in our decision boundary, that is our hyperplane. So W transpose X plus B here, the W is there. So if we put the value of the W, then we will get this equation. Similarly, for positive gutter, the equation of the positive gutter, if we just replace the value of W, then the positive gutter equation will be this one. For the negative gutter, this one is the equation of the negative gutter again. If we put the value of the W, then it will be this one. This one will be the equation of our negative gutter. Similarly, if we want to find out the width of a margin, then it will be M 1 by W plus 1 by W, that is 2 by W. where W is we know the value of the W. Okay, so the width of the margin we can also find out. On that case, maybe we will get two equations, and here is 3, 4, 5, 6, total 6 equations we will get. So using these 6 equations, we can find out the value of the W and also B. Then how can we do that? So now in our today's lecture, I want to start from this example. Okay, from this example, that means uh, how can you solve a problem? How can we train our support vector machine? Uh, Actually, what it will do in the training procedure, and how it will separate the different classes. Okay, so for that we can consider that we have a data set. Okay, we can consider a data set. Uh, the data set, maybe you can say a data set, many data we have, uh, and from those data set, from that data set, we can find out some of the support vectors. Okay, support vectors, we can consider our support vectors are just only A, B, and C. So A is 0, 0, and then B we have just 1, 1. Maybe you can say the data point is here. This is the B. The B is 1, 1. And we have also another data point, that is the C. Okay, C is 2, 0. Okay, 2, 0. I think it's better if we can draw it here. So our first data point is A, and that is the 0, 0. And the second data point is B. So this is B. Let's say this is the B, another data point, and that is 1 and 1. And then the third data point we have, it is 2, 0. Okay, so that is C. C is 2, 0. This is 1, 0, then 2, 0. Maybe this is the position of 2, 0. So here it is C. C is 2, 0. Okay, so these are the three data points we have. Three data points, A, B, and C. These are actually the support vectors. Okay, actually the support vectors. But we maybe different data points we have. Uh, like in this case, it is mentioned that we have negative points, that is A and B, 0, 0, and 1, 1. And we have a positive point, the positive support vector, that is C, 2, 0, that is 2, 0. Okay, that is 2, 0. So 2, 0, this one is our positive data point. So say this one is positive. And the 0, 0, and 1, 1, these are our negative data points. Okay, so these are our negative data points. Okay, negative data points. It means that in that data point, in that data set, we have many data points, and out of those data points, we find these three support vectors. Okay, that means there may be some other data points here, there, there, there. Okay, even there, and some other data points maybe here, there. Okay, so these are many data points we have. but we can see that these are the three support vectors. Okay, A, B, and C support vectors. Then how can we find out the hyperplane? Okay, how can we find out the hyperplane? Hyperplane, that means if we consider this is actually the two-dimensional data points, each and every data point has two features, x and y. Okay, x and y. So this is our x-axis and this is y-axis. So that means each and every data point like A has two values, 0 and 0. So that means we have two feature. One is x value and another is y. Another feature is y. For every data points we have two features, and that's why it's two-dimensional. So in such a case, if we want to uh, draw the hyperplane, then the hyperplane equation will be a kind of line equation. Okay, kind of line equation. That means uh, it can be any line equation like this. So this line equation, the hyperplane equation will be on that case it's a line equation. Okay. Now, how to find out that is the optimal value of m and c, because this is a line. It means in our line equation y equal mx plus c. So y equal uh, mx plus b, or you can say it is actually our w x plus b. So we need to find out the optimal value of the w and optimal value of the b. To find the optimal line, or we can say best separator line of positives and negative data points. So for that we will apply the equations we got from our optimization solution. Okay, from the Lagrange optimization solution. So now for that, what we can compute, like in step one, compute all kernel function values, which in this case uh, these are all dot products. Okay, um, it means we can see in our equations like here the hyperplane decision boundary. So we want to find out the decision boundary. Okay, in the decision boundary we have alpha I, yi, xi, and this is x. Okay, so alpha I, yi, xi, and x. So if we consider xi and x, those are the data points. So we can say xi and x. So those are the vectors, specifically the data points. Okay, and in this case the xi is our uh, support vectors. Okay, xi is our support vector. So it can be the xi. It can be what? It can be a support vectors. It can be b, that is a support vectors, or it can be c, a support vectors. Okay, it can be a, b, or c. Xi can be a. Another time it can be b. Another time it can be c. And how about the x? This x is fixed here in this case for a definite data points. Like we can fix the first time we can fix a, so that is a. Okay, next time we can fix b, like for the abc, a, b, c. Next time we can fix the b, that means we can say b here, b there, and b there. And maybe next time we can fix c. So xi, it will change like abc, and the value of x, first time you can consider a, second time you can consider b, third time you can consider c. So c will be fixed on that case. Okay, so uh, actually here is the xi dot of x. So this is the dot product of two vectors. Okay. Vector A and C, vector B and C and C, like this way. Similarly, vector A and A, vector B and A, C and A, like this way. Okay. So that's why, um, so at first we can find out the kernel function values here, k a, and then k ab, then k ac, and then k ba, k bb, and k bc, and k ca, k cb, and k cc. Okay. Um, so in this case, if we want to compute the KAA, okay, that means A and A. We want to find out the value of that A and A, like this one. So we have the data point A, the vector is 0, 0. So that means A, the vector is 0, 0, and then A also 0, 0, two vectors. Now we want to find out the dot products. Okay, so dot products on that case, uh, we will get 0 times 0 plus of 0 times 0. So it means 0 times 0 plus 0 times 0 is 0. Okay, so AA is 0. Similarly, if we want to find out this one, like BA, so B is what? B is 1 and 1. So that means 1 and 1. B is 1 and 1. And then A is 0 and 0. BA. So if we find out the dot product, like here 1 times 0 plus of 1 times 0. So what we will get, 1 times 0 is 0, 1 times 0 is also 0. So we will get 1 times 0 plus 1 times 0 is 0. That is BA. And we want to find out the CA also. So on that case, the CA, that means C times A. So C is 2, 0. It is 2, 0. And we have to multiply this one with um, CA. So A is 0, 0. It is 2 times 0 plus of 0 times 0. It is 2 times 0 plus 0 times 0 is 2. Okay, so uh, we already got these values. Similarly, we have to find out, uh, like this time, if we can think about finding out these things, that is A, B. A, B. So A, B, A is 0, 0, 0, 0, and B is our B is our B is our 1 and 1. So again, if we just multiply, so 0 times 0 plus 0 times
Sir,
1.
sir, uh, Kc of A, it should be 0, right? 2
K.
multiplied by 0
Oh,
plus,
it should be 0.
yeah.
It should be 0. KCA, it should be 0. Yeah. This one times that one. There is the C, 0 and 0, 0. Yes, it must be 0. Okay, thank you, Nila. And then KAB, KAB, it will be also 0. It will also be 0. KBB, BB on that case, B is 1, 1. So 1, 1, and also 1, 1. So on that case, 1 times 1 plus of 1 times 1, that is 2. Here is the 2. And then CB. C is our 2, 0. So that means 2, 0. CB is C is 2, 0. And then B is our 1 and 1. So 2 times 1 plus 0 times 1, it is 2. It is 2. And AC, A is 0, 0. And what about the C? C is 2, 0. So it will be 0 times 2 equal 0. 0 times 0 plus 0 times 0 is 0. So that is 0. And BC is B is 1 1 1 1, and then C is 2 0. Okay, C is 2 0. So it is 2. There is a 2. And how about C and C? C and C will be, C is our 2 0 and the 2 0. So it will be 2 times 2 is 4 plus 0 times 0 is 1. That is 4. Okay. Uh, so we compute all the kernel function values. This is in step 1. Okay. In step 1, that is just find out the kernel function values. Then is in step 2 we can see we will utilize these values, these kernel function values here. So we know that uh, that is alpha I y equals 0 from equation number 1. From equation number 1, alpha I yi equals 0. Okay, from this equation we know this one. This is the constant. Okay, and then we have we want to utilize another equation, that is our positive Gutter equation. So this is the positive equation of the positive Gutter. Okay, summation of I alpha I yi xi times x plus b equal 1, positive Gutter equation. And also the negative Gutter equation. Okay, negative Gutter equation is which one? This one is negative Gutter equation. Okay, summation of I alpha I yi and k x I and x plus of b equal negative 1. So this equation. Okay, if we utilize these three equations, 1 2 and 3. Okay, 1 2 and 3, these three equations here in this table, then in this formulation we can see that is for the case of the first equation, that is equation number 1. From here, the alpha I yi equals 0. So in this case we can consider that this, if we expand this one, actually we have three data points. Okay, then it will be actually the alpha a, the first data point ya, plus of alpha I is b yb, plus of alpha c and yc equal 0. Actually this is the equation. Okay, this is the equation. So in this equation there is no b. Okay, no b. That means we can say there is alpha a ya plus alpha b yb plus alpha c yc uh, uh, plus 0 times b. We can rewrite that equation in this way, uh, like this is alpha a ya plus of alpha b and yb plus of alpha c and yc plus of 0 times b. That means in this equation we don't have the b equal 0. So the first equation we can rewrite in this form, and we can see here alpha a ya and alpha c. But now we can see ya, what's the class level of ya? That is, in our case, the ya, it is the a is in negative class. Okay, it is negative class. A and b is negative class. C is positive. Okay, so that means from this equation, from this we can rewrite also this way. That is alpha a, but ya is negative, so negative 1 times alpha a plus of again b is also negative, so yb, that means there is the class level of b, it is also negative, times alpha b plus alpha c is yc is what, yc is positive class, so positive 1 times alpha c plus of 0 times b equal 0. Okay, in our C1, that is the constant 1 or equation 1, we have written this. So negative 1, so here is the negative 1, and then alpha A. So alpha A plus negative 1 alpha B plus positive 1 alpha C plus 0 B equal 0. So this is our C1. Okay, this is our C1. That is constant 1. From the constant 1, we can write this equation. Okay, now utilize the the second constant, that is this one, positive gutter. So positive gutter, you can see it is constant 3, and positive we have the positive point is C. Okay, the C is in our this point. If we draw the gutter, then actually where is that here? So if we want to draw the gutter, that is positive gutter. So positive gutter, this is the positive gutter. Maybe we can draw a positive gutter like this way. Like this way. Okay, so that means this is the equation of the positive gutter, where it will pass to our data point C. Okay, positive gutter. What is gutter? The equation of the gutter actually we have discussed in our last class. uh, so if we think the positive gutter, okay, this is our positive gutter, and this data point actually it will pass through just only one support vector, that is the C. Okay, that is the C. So for that, this is our C2, there is this our constant number 2, and it will pass only to our data point C. Okay, the equation will be on that case. What will be the equation? What will be the equation for the positive gutter? Alpha I, yi, k of xi and x. Okay, so the equation will be alpha I, so that means alpha A. Then yi is ya. Then k, that is the kernel of dot products xi. So xi is on that case a. xi is a because we are considering the data point a, and x, this x is fixed. So fixed, that means it will pass through the data point c. So that's why this one is fixed. This gutter, that is the positive gutter, it will pass through the C, data point C. So that's why the X is C. Okay, but Xi it will change. So the first Xi is A, then plus of alpha A, alpha A, Y, sorry, alpha B, then YB, K of um, there is a B, but we have to keep the C. Okay, plus we can rewrite this equation as alpha c, I equals c this time, y equals c, and k, here is our, this is the c, and c is fixed, plus, so here alpha I, y I, k, then b, then plus of b equal positive 1. So this will be the equation on that case. And in such a case, the alpha a, y a. So what will be the value for that? The alpha, the value of this part. Ya is ya. A is negative. Okay. B is also negative. C is just positive. So ya is the original class level of data point A. It is -1 times K of AC. K of AC we have already determined here. K of AC. So this is the K of AC. K of AC is 0. K of AC is 0 here. Times the alpha A. Okay. So alpha A plus, again for this part we can see YB. So YB is what? B is also negative. That means original class level of B is negative. So here is the -1. And BC, the kernel function values of BC, where is the BC? Here is the BC is 2. Okay, so we will get here 2. And then alpha B plus of alpha C, YC, and K of CC. Okay, so that means we have to consider YC. C is the positive. YC is our positive value, positive class, and KCC is 4. Okay, so we have to write here is it's 4 times alpha C plus of B equal +1. So now we can see this equation. We can see this equation YAKAC. So in this case, you can say YAKAC is 1 times 0 is 0. So that means -1 times 0 equals here -1 times 0, this part. So on that case, we will get 0. So here is the 0. And then alpha A, here is the alpha A plus. The next part is -1 and 2. There is the -2. So here is the second part is -2. Then alpha B plus. The third part we have here is alpha C and YC, and from there we got +1 times 4, that is 4. So here is the 4 alpha C, and the B, here's the B. The coefficient of B is actually 1. Okay, coefficient of B is 1. Here is the coefficient of B is 1. Then equal +1. So will equal +1. So this is another equation we got. Okay. Now we have to think about another constant, like constant number 3. So the negative gutter. The negative gutter. Okay, negative gutter. Uh, in case of a negative gutter, so this one and that one, these two are in our negative gutter. So if we want to draw the negative gutter, then we have to draw like this way, so that it can pass to both of this negative. negative support vectors. Okay, so A and B, these two are negative support vectors. So that means negative gutter will pass to this B and this A and B, these two support vectors. So at first consider that it will pass A. It will pass, the negative gutter will pass to A. So that means in this equation, equation number 3, the x, this fixed x, we will consider initially A. Okay. So that's what we have written here, that is C3A. So if this constant passed through the data point A, then on that case, so what we will get, alpha I yi k x I and x plus of B like this equal uh, -1. It means we will get um, alpha I initially we can consider A, and then yi, that is ya, and then k of xi and x. So we are considering A, so xa, that is A and x initially we assume that the gutter, it will pass to the first support vector, that is A. Okay, so here is the A. So that means this x, on that case this x is A, but xi it will vary like ABC. Plus alpha B yb, then k b A plus of alpha c yc k b c. Sorry, kb A. Is it B? No, it should be C. Okay, it should be CA plus of, we can see it is negative gutter, so plus of B equal negative, that is -1. Okay, equal -1. So from this equation, if we just put the value of y and also the kernel function values we got from this here, A and A, the equation will be like this way. Okay, so here you will get 0 alpha A, 0 alpha B, and then 2 alpha C, and then 1B equal -1. Similarly, the negative gutter, it will also pass to another data point, that is the data point B. So the same equation we can write on instead of just A, the, the fixed A, this time we have to fix B. So here is the, instead of A we have to fix B. Instead of A we have to fix B. So that means we will get the equation like this way: yakab equal 0 and alpha A. Here is the -2 alpha B and 2 alpha C plus B equal -1. Okay, so we will get another equation considering the negative gutter that will pass to our another data point, that is data point B. So now we have we got the four equations here, four equations. That is, this is equation 1. So that means negative 1 alpha A, negative 1 alpha A plus negative 1 alpha B plus uh, alpha C, that is positive 1 alpha C, and then 0 B is 0. So this is one of the equation. From this one, C3A, we will get, that is 0 alpha A, so 0 alpha A, and then 0 alpha B, so here is the 0 alpha B, and then 2 alpha C, here is the 2 alpha C, and then 1B, here is the 1B equal negative 1, negative 1. Okay, so similarly for C3B, from here we will get 0 alpha A, here is the 0 alpha A, and then negative 2 alpha B, negative 2 alpha B, and 2 alpha C, so 2 alpha C, plus 1B equal negative 1, negative 1. Similarly for the last equation here, alpha 2C, we will get 0 alpha A, so here is the 0 alpha A, and then negative 2 alpha B, so here is the negative 2 alpha B, plus 4 alpha C, here is the 4 alpha C, plus 1B equal positive 1. Okay, so these are the equations we will get. Uh, so now what we have to do, our target at first is to find out the value of alpha A, alpha B, and alpha C and B here. Okay, so that means we have unknown, four unknowns, and we have four equations. We have four equations and four unknown. So it means we can easily find out the value of alpha A, alpha B, alpha C, and also the B by solving these four equations. Okay, so utilizing these four equations. So if we solve those equations, then you will get alpha equal 0, alpha b equal 1, alpha c equal 1, and b equal negative 1. Okay, b equal negative 1 we will get. So that means alpha a, alpha b, alpha c, and b, the value of those four variables uh, already we can know those variable values. So now the target is to find out the W and B, but we have already got the values of alpha and also B. We know the alphas, those alphas are actually our Lagrange constants. Okay, Lagrange constants. So we already determined the values of Lagrange constants and also the value of B. Now, what we have to do, we have to find out the value of W. Okay, W. We know the equation of the W, that is from the equation number 2. This is the equation. Okay. From the equation number 2, we can find out now the value of W. Uh, it means the summation of alpha I, y, I, xi equal W. Okay. So it means it will be alpha I. Alpha I is alpha A, and then yi is ya, and xi. Okay, so xi is the a. A is what? A is 0, 0. class of alpha I, yi, and xi, where we can consider I is b. Okay, in that case we will get the alpha I is alpha b, yi is yb, and then we have yb is b is what? B is 1 1. There is our x b plus we have also another that is uh, term. Another term is alpha c. So alpha c yc and xi. So xi is our c. C is 2 0 2 0. So this is equal w. So now we want to find out the value of the w here. Alpha a. Alpha a, the value of alpha is what? Alpha a, we have already determined the value of alpha. Alpha a is 0. Okay, so we can write it like this: 0 times ya. Ya is our class level of a. So class level of a is, for the a, the class level it is negative, negative 1, and 0 0. Then alpha b is also negative, and yb is what? Yb is, okay, alpha b first, the value of alpha b. The value of alpha b, we got alpha b is 1, positive 1. This is positive 1. Then alpha b yb is negative 1. Yb, and x2 is 1 1. Okay, then alpha c, what's the value of alpha c? Alpha c, value of alpha c is also 1. And yc is negative. And x free xc. Okay, so there is our 2 0. Okay, equal w. Okay, equal w.
Sir, YC was positive, right?
Yc, it is positive. Yes, I think so. As per, yeah, c is positive. So what's the value of our alpha c? The value of alpha c, alpha c is 1. Okay, so that means positive. So here is the positive, and then yc is positive, so here it must be positive. And the c, the our vector c, so the value of our vector c is 2 0, equal w. Okay, equal w. Now now what we have to do, okay, I have to do the math. So here 0 minus 1 times this vector is, we will get 0 here from here. Okay, actually we will get a 0 0, and then from here next 1, and here is the minus 1. Okay, minus 1, so that is our negative 1. If we multiply this vector by this negative 1, then we will get negative 1 and negative 1, then plus positive 1 and positive 1, and here is the 2 and 0, so that means it will be 2 0 equal w. So it means, so these are the three vectors. We want to just sum up these three. So 0, and then negative 1, here is the 2. So that means if we do the math, then we will get 2 minus 1, that is the just 1. And then next is 0, minus 1 and 0. So if we sum up these three, so we will get negative 1 equal w. So that means w is a vector, and in that vector we will get the vector value 1 and negative 1. So we got the w, and this w equal 1 and negative 1. So this is our w. The optimal value of w will be this 1 and negative 1. And how about the b? We have already calculated the value of b. Optimal value of b is negative 1. Okay, so optimal value of b is negative 1. So we got the optimal value of w and also b. Now if we want to find out our hyperplane equation. So find out our hyperplane equation. The hyperplane equation we have, that is, if we can remember that, the hyperplane equation, it will be w transpose x plus b equal 0. Okay, so in such a case, we have w. The w is 1 and negative 1. So that means if we do the transpose here, that is 1 and minus 1. And x, in x, that means x is a feature vector. So we have two-dimensional vector. Let's say x and y is our dimension, two dimension. Okay, and plus of b. B is what? B is negative 1. So that is negative 1 equal 0. So it means the equation will be, hyperplane equation will be 1, there is this 1, there is this x, so that is x minus, there is a minus, okay, and here is a y. So that means it is minus 1 times y is minus y, and then plus minus minus 1 equal 0. So x minus y minus 1 equal 0. So this is the equation of our hyperplane. Okay, this is the equation of our hyperplane, x minus y minus 1. So now we got the optimal value of w, optimal value of b, and then the equation of the hyperplane also. Then if we want to plot this equation in our data point, so our equation is what? Equation is x minus y minus 1 equals 0. Okay, this is the equation. So we want to plot this equation here in our data scatter plot of our data set. Then to show that is which one is our hyperplane here. So if x equals 0, what will be the y for that from this equation? X equals 0, then y equal negative 1. Another case, if y equals 0, then x will be 1. Okay, so that means when x 0, y negative 1. When x 0, in this plot, when x 0, y is negative 1. Okay, y is negative 1. Maybe you can say negative 1 is here. And another one is when y 0, x equal 1. When y 0, x equal 1. So x equal 1 is this one. Okay. Uh, so y 0, x equal 1. That means this is the data point. Now if we just draw, we can connect these two data points and extend it further. Okay. So this is our hyperplane equation. H x minus y minus 1 equal 0. The hyperplane equation. Okay, this is the equation of our hyperplane. So it means that this hyperplane equation, we can see it is this side is positive. Okay, this side is positive gutter, and this side is a negative. Those negative data points, and this is the negative gutter, and this is the positive gutter of that. Okay, so we got the hyperplane equation. Now the last thing is we want to test any data point whether the data point is positive or negative. Okay, that means whether based on the data point values, it will be in positive class or maybe in negative class. And for that, maybe we can consider any data points, random. We can say a data point is P, and then the value is like zero point 0.2 and -2 and maybe positive 3. So whether this data point is in positive class or maybe in negative class, we want to test it. And for that, what we have to do, again, we will utilize the equation W transpose X plus B. W transpose X plus B. So now we can see that if we put the value W, what's the value of the W? The value of W is, we have already determined, 1 and -1. 1 and -1. That means if we do the transpose, then it will be 1, -1, and then X. So this X is now, we can see this X is now our data point. So data point, this is P. So P is here, that is -2 and here is 3. Plus of B. B is what? We have already calculated the value of B
-1.
to -1. Okay, thank you. B is -1. So now, if we want to compute the value, this one and that one, here is 1, here is -2, that is -2 plus this is -1 and here is 3. So it means it is also -3, -3 plus -1. -2, -3, -1. That -6. -6. Okay, and the point, the sign is important here. Okay, sign is important here. That is -6. Okay. Now, if we can plot this, that is -2 and +3 here. So -2 and +3. -2, you can see 1. Maybe -2 is here. -2. Uh, oh, sorry. -2 in x-axis. So that means in this side. -2. +3. So +3, it means maybe this side, and then +3 is y is +3. Maybe here. Maybe we will get that data point here. So actually, this side is what? We can see this side is negative side. Okay, actually this side is negative side. And our algorithm or our hyperplane is also mentioned that the sign of this value is negative. It means negative. Okay, it means negative. The data point will reside on negative class. So that the point P is a data point of negative class. Okay, so that's true. Okay, So our uh, hyperplane classify the new data points successfully. So this is how we need to solve any problem if the data points are given, data sets are given. So the first thing is we have to determine uh, our support vectors, and then based on the support vectors, uh, we have we have to utilize those equations. Okay, utilize those equations, find out the uh, dot products of the kernel values, and then use those to form different equations. And on those equations, we have to uh, find out the value of Lagrange constants, and then utilizing those Lagrange constants, find out we have to find out the value of the W and also B. Uh, After that, utilizing those W and B, we have to uh, find out the hyperplane equation, and utilizing those hyperplane equation, we have to classify the positives and negatives. Uh, so, do you have any question here in this discussion? Do you have any question?
No, sir.
Okay. Uh, Here is another example is given also. Okay, like the data points are given. From the data points, at first we need to find out the support vectors. Okay, maybe you can consider this one, that one, and this one as our support vectors. And if the data points are given, then actually uh, for the training purpose, it's the class levels are also given. Okay, so like in this case, uh, it will be given that okay, maybe this is the positive class, so these data points are in positive class, these are in negative class. Okay, so it will also be given, and then you have to find out the support vectors, and utilizing that those support vectors, and also utilizing the equations we have already derived, you can easily find out the hyperplane, and also there is the you can classify any new data points, whether that one is in positive class or in negative class. I think you understand the procedure of our support vector machine. Uh, we will discuss about the specifically the nonlinear support vector machine in our next class. I am currently at the university, and it is mentioned that okay, electricity will be cut down soon because they are working on the electricity line. So maybe I need to stop here. Then in our next class, we will discuss about our non-linear support vector machine. Any question, any queries from your side?
Sir, I had a query about our finals. So I think our final is scheduled on 20th, 19th. So what will be our syllabus?
Uh, Whatever we can cover up to that lecture, okay?
After
Up to the
from
day,
the mid.
yeah, after mid.
Okay. And will there be any other assessments before the finals?
Yeah, that's also another question. We have planned that we will take just maybe another presentation, and then I will provide some assignment. You have to complete those assignments also. But this time, maybe I will not take the projects. Okay.
Okay, sir. Thank you.
স্যার আমাদের কুইজ নেওয়া হয় নাই মানে এই কোর্সের কোনো
Yes.
স্যার
In
কি
our next class, I will take. I will conduct just the first quiz.
Then, sir, what will be the syllabus for that quiz?
Yeah. How about the support vector machine? We just have learned last two classes.
Okay, so this class and the previous class.
Yeah.
ওকে স্যার
So in our next class, it will be offline class, and on that offline class, at first you have to sit for the quiz, and then maybe we will continue the class.
Sir, is there any alternative if I miss the quiz for some reason?
You want to
Uh,
miss there's only one quiz.
no, sir. Actually, I didn't know that. I do have another thing planned on that day.
Okay, no problem. You can, I think, you can sit for the makeup quiz.
Okay, thank you, sir.
Okay.
Sir, class will be started from 6:30.
Class will be started from 6:30. Yeah, offline class
Sir, and final syllabus will be from after the meet.
after the meet.
Okay, sir. Thank you, sir.
Okay. Okay. Thanks everyone for joining this session. Thank you.
Thank you,
থ্যাংক ইউ
sir.
স্যার